Alright. Hello, boys and girls. This is Mr. Kizik, and in this video, we're just going to look at part 2 here of looking at the answer. Hopefully, you got for number 5, and then looking at some algebra. So, with number 5, AC is 42 because diagonals are congruent. AB is 21 because diagonals bisect each other. BC is 26 because opposite sides are congruent. And AB is 33 because we have a right triangle with the hypotenuse 42 and one of the legs 26. So the problem's set up there. Measure of angle ADC is 52 because, oh, I'm sorry. Wow. Yeah, I'm an idiot. ADC is not 52. ADC is 90 degrees because it's the corner. That's a property there. Measure of angle ABD is 38 because it's 90 minus 52. Measure of angle BCA is going to be 52 because it's alternate interior to the original angle that you're giving. And the measure of angle DEC is 104 because if I know these two angles in the bottom of 38, I know triangles up to 180, so 180 minus the 38 added together. Again, if you got any questions, feel free to ask me. Moving right along here with the algebra, though. So, just like parallelograms, you're going to utilize the properties of rectangles to determine how to solve problems. So if I look at number 6, find EF. Well, look here, based on what they gave me, what do I know? I know opposite sides are congruent. So 3x plus 5 equals 7x minus 39. Let's see, I add 39, I get 44. Subtract 3x, I get 4x. X equals 11. So to find EF, I just plug in 11 for x. And I would get 77 minus 39, which is going to give me 38. Number 7, RT, they gave you that. US, what are RT and US? If I look in the diagram here, they are both the whole diagonal. And what we know about diagonals in parallelogram, rectangle, they are congruent. So we set them equal to each other. So then we set them equal, and we get, let's see, 3x equals 24, x equals 8. But what do they want you to find? They want you to find VT. I still got to plug it in. Let's just say we plug it into RT. So 5 times 8 minus 14, which is going to give me 26. Yeah, 26. But that's RT. If I want to find VT, I need to divide it by 2, and I would get 13. Right? Whereas number 8, what's a little bit different with the setup, besides finding different sides, they gave you JM, which is from here to here, and then they gave you MK. Well, actually, in this case here, they're the halves of the diagonals, but they're still equal to each other. So x plus 17 equals 5x minus 23. Subtract x, add 23, I get x equals 10. And they want you to find JL. Well, I can plug it to JM. So if I plug in the JM, I get 10 plus 17, which is 27. But that's only from J to M. I want JL, so I multiply by 2, and I get 54. Let's look at the next one, VW. Or number 9. VW from here to here. SU is from here to here. Do I set those two equal to each other? Hopefully your answer is no, you do not, because if I look here, they're not the same thing. I mean, visually, they're not the same. So how do I make them equal? Well, in order to make them equal, I have to take VW, 9x minus 11, and multiply it by 2 because it's half of the diagonal. So equals 16x minus 12. And now you just go about solving for it. 18x minus 22 equals 16x minus 12. When I rearrange everything, get 2x equals 10. Yeah. And x equals 5. And what do they want? They want WT. Well, I realize WT is the same thing as VW, so plug it into there. 9 times 5 minus 11. 45 minus 11, 34. Same concept goes for the angles here. I'm not going to do all of them because, again, there could be many different possible ways. You're just going to utilize it to determine how to set up the problem. So for number 10, I'm not worried about saying what it's asking for, but based on the angles that they gave you to solve for x, these are alternate interior angles. And what do we know about alternate interior angles? They are congruent. So set them equal to each other. So when I do solve for it, I do get x equals 2. But what do they want? They want angle BCE, which is this one right here. Ah, gee, they didn't give me anything to plug it into. Well, I know I need to plug it into the one next to it, so let's do that. 11 times 2 minus 3, which is going to get me 19. Well, if this is 19 degrees, oh boy, I wish I knew this entire angle measure. Oh, I do. That's the property of rectangles. Rectangles say the corners are 90 degrees. So I'm going to take 90 minus 19 to get that other angle measure, which is going to be 71 degrees. For the next one, so based on the x's that they gave us here, these two angles are next to each other. They're right at the same corner. And what do we know about the corner of a rectangle? The 90 degrees. So we're going to just add them together and set it equal to 90 degrees. So you just combine my terms. I got 15x minus 15 equals 90. We're going to add 15. 15x equals 105. And then I'm going to divide by 15. And I'm going to get 7. Now I want to find angle JHI. So if I trace that out, it would be right here. Well, which angle is that? That's this angle right here because it's alternate interior to that. So I take 3 times 7 plus 2, 21 plus 2, 23 degrees. If I look at number 12, same thing here. How are these? Don't worry about what it's asking. Just worry about what's the relationship. Well, the relationship between the two may not look like it, but remember this angle here is congruent to this angle here, and this angle here is congruent to that angle there. So that means, again, this is just like number 11. These are part of the same corner, which means they would equal 90 degrees. And then, so, you add them together, x plus 20 plus 5x minus 8, set it equal to 90. 6x plus 12 equals 90. 6x equals 78. Yeah. And then x is going to equal what? 13. Now I want xzw. xzw is what I labeled right here. So in order to do that, well, that's this angle here. So I'm going to do 5 times 13 minus 8. 5 times 13 is doing a little math. 65. Yeah, 65. 65 minus 8 is going to be 57 degrees. Last one here. So with this here, now they gave you 5x plus 7, which is that corner there, and 134, which is in the middle. Unfortunately, these do not equal 90 because obviously 134 is already bigger than that. And they only give you the angle next to it, so I can't add anything to make it 90. However, this is what I can do. And again, there's usually more than one way to do a problem. I can figure out this angle right here by taking 180 minus 134, and that's going to give me 46 degrees right here. Remember what we talked about before in part 1? This is an isosceles triangle, which means these two angles here are the same. I have all three pieces of information for my triangle here, so I can add them together and set equal to 180. So basically 2 times 5x plus 7, because that occurs twice, plus 46 equals 180. I can distribute 10x plus 14 plus 46 equals 180. 10x plus 60 equals 180. 10x equals 120. X is going to be 12. And that, ladies and gentlemen, is how you utilize algebra, utilizing the properties of rectangles and algebra here. So what I would like you to do for homework is I would like you to try the odd problems of this. It's not loading here, but I'm assuming there's a front and back. I'm going to just check here just to make sure. And yes, so I would like you to do the odds front and back of this worksheet. Again, if you have any questions or concerns, please feel free to email me. Ask me during class. This is Mr. Kiesik, signing off.